In this session, we are going to discuss about the magnetic field due to a current in a solenoid. Solenoid? The name sounds scary, I know, but the idea behind it is really simple. Surprised? Okay, let's create one then. What you have to do is take some cylindrical object like a cardboard and wind many turns of insulated copper wire around that object. Your solenoid is ready now. Now I think it's pretty easy to define a solenoid. We can define solenoid as a long cylindrical coil which has many circular turns of insulated copper wire wrapped closely in the shape of a cylinder. That's it. That's what a solenoid is. But why are we studying this? How is it related to the magnetic effects of the electric current? If we allow an electric current to flow through it, then each turn of the coil behaves like magnet. Little surprising, right? Let's find out with the help of an experiment. Here, I'm connecting the solenoid with a battery and a key. Now, as you can see, I'm allowing the current to flow in the clockwise direction. We also need a bar magnet for this experiment. What happens if we take a south pole of the bar magnet close to the left side of the solenoid? You will observe that the bar magnet is repelled by the solenoid. And if we place the north pole of the bar magnet close to the left side, you will see that the magnet is getting attracted. So it's pretty clear now that the left-hand side of the solenoid is acting as south pole. And if we perform the same task on the right-hand side, we will notice that the right-hand side acts as north pole. This is when the current is flowing in the clockwise direction. Now what if I allow the current to flow in an anti-clockwise direction? Exactly. The left-hand side of the solenoid will act as a north pole and the right-hand side as the south pole. If we look at the magnetic field pattern of a solenoid, this is how it would look. Does it look familiar? Yes, it's similar to that of a bar magnet we'd seen earlier. Within the loop, the field lines go from the south to the north and then go about outside and come back to the south pole. Now tell me, do you think we can increase the magnetic strength of a solenoid? If yes, then how? Exactly. We have to increase the number of turns. More the turns, more will be the magnetic strength. So we know what a solenoid is and how it acts as a magnet. Now what can be the use of this strong magnetic field produced inside a solenoid? It can be used to create an electromagnet. What is an electromagnet? In the year 1825, William Sturgeon found that if a soft iron core is placed inside a solenoid with a strong magnetic field inside it, then that soft iron core is magnetized. The magnet so formed is called an electromagnet. To learn more about the applications of an electromagnet, stay tuned for more videos.